Hi, and welcome to Concept 1450. We're going to use properties of radicals to simplify expressions. Perfect square. A perfect square is a number made by squaring an integer. Squaring means taking it times itself. Here's a list of perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on, all the way up through 20 squared, or 20 times 20 is 400. A radical is an expression that has a root. There's a symbol for root, and we call it a square root. We call it a square root because it is going to say what number times itself. That is a square root. Notice there's not a 2 here, but it is implied that that is a square root. We also have a cube root and a fourth root, but we're going to be focusing mainly on the square root. If I said, what is the square root of 9, I would be asking you what number times itself is 9, and that answer is 3. Another example, what is the square root of 16, or what number times itself equals 16, and that is 4. So how do we simplify a square root? First off, we need to see if the number is a perfect square. If it is, all you need to do is simplify that. If it's not a perfect square, then we're going to go to step 2, and we need to find the largest perfect square that is going to divide into our number. We would then rewrite the square roots as 2 roots that are being multiplied and simplify that perfect square. All right, let's do some examples together. Looking at the first one, the square root of 16. Look back at your list. Does the square root of 16 have a perfect square? And it sure does. 4 times 4 equals 16, so the square root of 16 is 4. If we go to the next one, it's asking us the square root of 40. So 40 does not have a perfect square. What I would recommend doing is looking at your list and identifying where 40 falls. And it actually falls between 36 and 49 right here. So we need to look at all the numbers less than 36 that are perfect squares that might go into 40. And the only number that I can see that goes into 40 is 4. So we're going to split this and say the square root of 4 times the square root of 10. And I chose 4 and 10 because 4 times 10 equals 40. Now I can simplify the square root of 4 to be 2. And we can't simplify the square root of 10, so our answer is just 2 square root of 10. We're going to do the same thing on 20. Find where 20 doesn't have a perfect square. So what number is a perfect square that goes into 20? And as you can see, 4 times 5, and 4 being the perfect square. So if I take the square root of 4, I get 2, and we leave square root of 5. 32. Again, I'm looking on my list. It's going to fall between 25 and 36. So what numbers between 1 and 25 on the list will go into 32? And we were trying to pick the largest one, remember? So 16 times 2 is 32. So we can simplify the square root of 16 to be this 4 times the square root of 2. I've already done the square root of 40 there. So let's look at 27. That would be the square root of 9 times the square root of 3. And if we simplify the square root of 9, that's going to be 3 square root of 3. And 14, I'm looking, 9 can't go into 14, 4 can't go into 14, and 1 can, but it's not going to help us with simplifying that. So if you can't simplify it, you're just going to put can't simplify and leave it as the square root of 14. Now, how do we simplify a square root with a fraction? If either the numerator or the denominator are perfect squares, then you're going to simplify them. If there is a radical on the top, simplify it and find the biggest perfect square that divides into it if possible. If there is a radical in the denominator or the bottom, then you must rationalize it. is what it is called. We're going to do that by multiplying the top and the bottom by whatever the denominator is. So let's take a look at some of these examples. Square root of 49 over 225. What I like to do is simplify that. So we can take the square root of 49, that's 7, and we can take the square root of 225, that's 15. Because both the numerator and the denominator are perfect squares, you can simplify them and leave them in fraction form. Notice the radical symbol goes away once you have simplified that. Look at the next one. Square root of 100 divided by square root of 81. 100 is a perfect square and simplifies, and 81 is a perfect square and simplifies. So you can simplify each of those with your answer being 10 over 9. The next one, square root of 5 over 36. The square root of 5 cannot be simplified, but we can find the square root of 36. So that's going to simplify to the square root of 5 divided by 6. This next one, the square root of 10 divided by the square root of 169. 10 is not a perfect square, so we're going to leave the radical in the numerator, the square root of 10, and we're going to take the square root of 169, and that's going to simplify to 13. So 10, square root of 10 over 13, it would be your final answer. All right. Then here comes the next part. So we're going to simplify again the square root of 36 divided by the square root of 5. We can take the square root of 36. That's going to simplify to 6. So we've got 6 over the square root of 5. Now, if you look back at your notes, it says if there's a radical left in the bottom, you must rationalize it by multiplying the numerator and the denominator by whatever is in the denominator. So we're going to take the square root of 5 and multiply square root of 5 by the numerator and the denominator. By doing that, when we multiply fractions, you just multiply your numerators together and multiply your denominators together. So by doing that, the square root of 5 times the square root of 5 is the square root of 25. We now are able to simplify that radical. So in the numerator, we're just going to take 6 times the square root of 5, and we're going to leave it 6 square root of 5 in the numerator. And now that we have the square root of 25 in the denominator, we can simplify that to 5. So our final answer is 6 square root of 5 divided by 5. Looking at the next one, the square root of 25 divided by the square root of 6. We can take the square root of 25, that's going to be 5. And we're going to need to leave square root of 6 in the denominator. And now we need to rationalize that. So we need to take the numerator and the denominator and multiply by the square root of 6. When we do that, again, we're just going to multiply straight across the numerators. So our numerators 5 times square root of 6, and multiply the denominators, which gives us the square root of 36. And when we simplify that, 5 square root of 6 divided by 6. Square root of 6 divided by the square root of 11. Now, neither one of those are perfect squares, so we're going to simplify by having the square root of 6 divided by the square root of 11. And then we'll rationalize that by multiplying by the square root of 11 to the numerator and the denominator. When I take 6 times 11, I get the square root of 66. And unfortunately, I can't simplify that at all, so that's going to stay the square root of 66 in the numerator. But the square root of 11 times the square root of 11 is the square root of 121, and that simplifies to 11. Something that I think is important that I need to probably discuss real quick is if I take the square root of 11 times the square root of 11, that's the same thing as the square root of 11 squared. Squared and square root will actually undo each other, leaving us with that 11, and that's the same as taking the square root of 11 times the square root of 11, which is 121, and then simplifying. Both are going to get you that whole number in the denominator. All right, the last one here. 7, square root of 7 divided by the square root of 2. Neither one of those are perfect squares, so we're going to need to rationalize that by multiplying by the square root of 2 to the numerator and the denominator. We can simplify that to be the square root of 14 over 2. All right, go ahead and pause the video, try the independent practice on your own, and then check back for your answers to see if you did it correctly. All right, hopefully you were able to get all of those correct. If you have questions, please make sure to ask before moving on to your teacher talk.